Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And we have a really good topic for today. It's actually one I've been wanting to dig into for a little while because I everyone hears a lot about this whole concept of AI and hallucinations, but I don't know that anyone has ever really kind of dug into them specifically as a topic here on the show before. So, for that, today we have Anand Kannappan. And Anand, you are the CEO of Patronus AI. So, first of all, Anand, welcome to the show and give everyone a quick introduction, please.
Absolutely. Thanks so much for having me on, Aaron. So I'm co-founder and CEO of Patronus AI. We do everything related to AI optimization and evaluation. So helping companies be able to ultimately reduce AI failures like hallucinations and other kinds of unexpected behavior from LLM systems. And we have a unique AI research first approach to how we solve that problem, especially because we primarily focus on automated ways to detect different kinds of failures. And some of our customers include companies like Etsy, AngelList, and HP. And so my background is primarily in ML interpretability and explainability, and I'd helped lead a lot of those early machine learning efforts at Meta before. Since we got started, a lot of what we solved for companies around the world that are building new AI products is ultimately addressing some of the most challenging failure modes that AI engineering teams are running into, especially as they are developing new agentic systems and RAG systems. And so, all of us at Patronus are very excited to bring a very research first perspective to solving this problem, and that's exactly what we do at Patronus.
Fantastic. And as I mentioned, we definitely want to talk about preventing AI model hallucinations and optimization. But before we dig into all of that, I really wanted to also talk to you a little bit about your time at Meta and lead data scientist at Meta. What was it like, first of all, in the early days within that organization, and what did you kind of learn there, and what did you take away from there? I'm sure it's something you get a lot of questions about.
Absolutely. So I'd say I think my time at Meta was incredible, especially because it was a time when things like data infrastructure, data science, data engineering, and just machine learning were scaling very quickly internally. And it was both from a product perspective, which meant scaling things like recommendation systems and ranking systems for, of course, global products like Facebook, Instagram, and others, but also a lot of work that was done internally to be able to optimize those kinds of systems and also just to be able to understand what's working and what's not working really well. And so it was a time when I would say most people in the market describe the culture at Facebook as being extremely data driven. And so the kinds of infrastructure that was built internally was incredible. I think even today, that kind of infrastructure is not even available from a third party perspective for anyone, several years later as well. And so I'd say from a culture perspective and internal tooling perspective, there's a lot that I took away from my time there. And apart from that, of course, the framework, the methodology to which internal teams were approaching things like interpretability and explainability were really top tier, I would say. And so a lot of things that we learned during our time are things that we're applying for customers today that are attempting to solve similar kinds of problems within their own organizations. I thought I'd also mention my co-founder and CTO, Rebecca, who also actually came from the AI research group at Meta as well. And she was actually focused on driving forward responsible NLP research. It was a time when not a lot of folks were really talking about any of this. And of course, all of a sudden, since 2022, it's become at the forefront of what companies really need, especially as they are developing new AI products and getting to production. And so really excited to be able to bring that forward to everyone around the world.
No, I love that. I love that. And Anand, let me ask you this because I want to dig into this idea of model evaluations and hallucinations. So let's kind of start at the beginning and set some foundational kind of groundwork, if you will. First of all, what is the most common approach to evaluate a model today? And then, other than, we kind of see hallucinations and we can kind of see them in real time with some of the big frontier models that are out there today. But other than kind of someone looking at that and going, that's not right. Like, how did model hallucinations even kind of come about? Kind of give us a little bit of a history and information about everything, real quick.
Yeah, absolutely. So I'd say what's interesting is that when Rebecca and I first started the company, we actually debated whether or not we should use the word evaluation in our messaging because it was a research term at that point and no one knew what it was. And so, of course, a lot of that has changed now in the last 12 to 18 months. And it's super exciting to see every single AI engineer out there be able to think about this problem and figure out how to solve it for their own kind of product that they're building. And so I'd say the word evaluation has in some ways gotten very bloated over time, where it sort of means experimentation, and for some people means observability, for other people means guardrails, and so for other people means all of the above. And so it's in some ways gotten very confusing, but in a lot of ways, at its core, it's really about performance measurement. It's really about how do you really figure out what to do next. And so the way that we approach evaluation of Patronus is very much around that latter, which is around how can you actually action on the failures that you're seeing, and how can you do that in very highly intelligent ways. So today, I would actually say that the common way that most people approach evaluation, to your question, is uh, uh, you can have some kind of predefined evaluator function that you can write in code that is focused on testing something that is very specific. So maybe you want to make sure that the output has a very specific word or character in the string. Or maybe you're checking to make sure that the numerical value falls within 10 to 20, for example. And so those are things that, of course, could be useful if you are building something that is meant to be very, very deterministic and something that you have full control over. But of course, one, I would describe that as fairly rudimentary. And two, I actually think it, in many ways, may not even be as relevant, especially as we enter a world where companies are developing multi-agent systems, where agents are actually acting completely on their own, and they have completely unpredictable trajectories. And so, of course, in those kinds of scenarios, what's really important is the ability to have intelligent feedback, intelligent supervision of AI products. And that's exactly what we focus on at Patronus. And we've been able to do that for a variety of different kinds of modalities, including, for example, most recently for folks that are building multimodal image use cases, where a few weeks ago we announced the first multimodal LLM as a judge that developers can use to be able to systematically test against image input to text output use cases, and to be able to address things like caption hallucinations, for example. So that's an example of a scenario where one of our flagship customers, Etsy, was able to be able to understand how to prevent caption hallucinations from happening by using some of the by using things like our multimodal LLM judge. And
Gotcha.
so I'd say that hallucinations are certainly a very challenging problem, and it's become a much more of a mainstream word. But we at Patronus typically approach hallucinations as something that is more from a technical definition perspective, which is are outputs actually grounded in the context that was ultimately passed in, and that's one of the key ways that things like links, which we've developed, an evaluation model that we developed, is grounded in order to ultimately help companies be able to score and optimize their RAG systems, for example.
Got you. Yeah, because I'll kind of ask a follow up to that because yeah, I like this whole idea of the this idea of like, okay, you've got the size of the model and certainly the complexity of all of these and the amount of parameters that goes into it. And sometimes, I mean, it's not like you can just fact check these things manually, right? Like it's not like the old days of Q&A testing and verifying inputs and outputs, right? And so when you said you have a model, tell everyone a little bit more about, okay, that evaluation. How do you do the evaluation, and then how do you have a level of confidence from those results that you kind of go, okay, this is a hallucination or this isn't a hallucination? Is it easy to do like a simple binary evaluation of that, or is it much more complex than that?
Yeah, absolutely. So I'd say the ways we approach evaluation really ends up, depending on the specific use case or domain, and goes beyond, binary evaluations as well. And so we've supported a variety of different kinds of use cases and scenarios that are typically more complex and challenging. And we've seen that over time, of course, most companies and developers are not really dealing with model-specific problems, but they're actually dealing with system-specific problems. So we usually say it's about evaluating LLM systems and not about just evaluating LLMs kind of in isolation. And so when it comes to how we develop our evaluation capabilities, like for example, our Patronus evaluators, we actually, for example, have trained evaluation models that are designed, in nature to be specifically good at that particular task. And the way that we ultimately ensure the quality and the confidence of those evaluations is we actually do a lot of internal research and benchmarking in the form of human evaluator alignment. And so we actually have internal data sets that we've constructed where we have the evaluators score against them, and then we have humans separately also score against them, and then we benchmark them to understand what is the agreement rate between what Patronus evaluators think versus what humans think. And of course, that's a process that we take very seriously inside of our research team. And as we bring it to customers and as we engage with them, one of the things that they care about is the quality of the evaluators, and they want to make sure that it ultimately aligns with their specific use case. And so the benchmarking numbers that we provide for them are evidence of that. But of course, it all depends on how well it really works in the real world. And so that's kind of how we approach that. The second big thing I thought I'd mention is that I'd say that we approach evaluation from a very kind of rigorous quantitative perspective. And I actually expect that as the field evolves over time, I actually expect more and more engineers to become very fluent in statistics if they aren't already, mainly because so far I would actually describe that most people are approaching evaluation with, to some level, bad science. And maybe that's a bit of a hot take, but I think a lot of people are actually doing evaluation wrong. And it's because, a lot of times you're just looking at point estimate comparisons. You're just running it against some kind of evaluation data set that you put together. You don't even know if the sample size is large enough. You don't even know if the data quality is high enough. So we're seeing all kinds of bad practices happening. But I expect that as the market matures, more and more folks will be approaching this much more rigorously. And so one way that we enable that in our product is we actually offer a really high quality suite of features around explainable evaluations in particular. So the key word is explainable. And so what that actually means is, to your question, you not only see scores, but you also see explanations for those scores that are in natural language. You also see, for example, outputs that have specific highlights of spans to really pinpoint where precisely the failures are, which could be pretty useful if you have long outputs, for example. And then also we offer things like confidence intervals and other kinds of things to really just tell you in more depth why you saw the score that you saw and what can you really do about it ultimately. And so a lot of what we see developers really gravitate towards is understanding what actually happened and trying to interpret what they can do next, and then actually taking that action, all within their product.
No, I love that, and I also like too the whole mention of the concept of data quality, and how that could potentially play into this. Like, does it make sense then to kind of ask this question of like, okay, how do you know when a model it just wasn't given, either it wasn't given the right data or it wasn't given an insufficient amount of data versus it just flat out hallucinated?
Yeah, I'd say that typically what we've seen, especially become more challenging for companies that are developing, different kinds of LLM systems like RAG systems or agentic systems, is this a problem around data quality as it relates to context in particular. And so how I describe that is. Context itself is about what you're really passing to the LLM as some kind of data source, or even a chunk from the data source, if that makes sense. And so context is not just about having information that the LLM itself can access, but it's about having the right information with the proper framing. So for example, when you're given 10,000 pages of financial documents, it's about actually knowing which 10 pages actually matter. And so, of course, something like that is very core to every LLM system, whether you're building copilots or agents or anything else. And so And so I'd say that, especially as we see LM capabilities increasing over time, I actually expect that the success of AI products that companies are developing, they're going to depend a lot more on context quality rather than LM performance itself. And I'd say that that's because, there's a lot of examples now where LLMs themselves are actually really quite capable when the context itself is shaped properly. And so I'd say that shaping context or shaping the data will actually be a really big problem for AI teams to really figure out. And so what we're telling customers is three big things. One is that means that moving forward over the coming months and years, internal data management is really key. And so as an AI team, you should be investing a ton in data annotation, data observability, and even subject matter expertise as early as possible. And so that means that you need to know exactly when you need more data, when data is out of date, and even when subject matter experts should be in the loop. Number two is, I would say, high quality and reliable evaluation and optimization is just significantly more important than ever because you want to be able to measure the quality of data, quality of context before you pass it in to your system. And so that could be in the form of measuring context relevance or context efficiency. And those, I would say, are just prerequisites before you even launch any kind of AI application. And then the third big thing I'd mention is building or shaping that context is really done best when you can kind of really carefully experiment and iterate over it. And so I'd say there's actually a really kind of tight feedback loop between context and inference. And so that means that if you have really good context or really good data, it then leads to good inference over that context, which then, of course, then leads to better context, and so on and so forth. And so I'd say that it's a really important piece to solving the big hallucination problem. And so we're really excited about how the industry is going to tackle problems related to context quality in the coming months.
And maybe a follow up related to that kind of on the data quality standpoint. I mean, we hear all the time about, especially in the frontier models, they're kind of running out of training data, and we've talked on the show many times about either synthetic data or insertion of data to maybe potentially mask, like say, private information, right? Like maybe let's give you an example. Like an organization wants to be able to potentially tap into customer data, but they of course want to hide the details of that data. So they will either generate synthetic data based off of it, or they might mask it in some way. Does hallucinations or kind of the optimization, does it factor in then in how that affects ultimately how well everything performs? And it is something, say, developers or data scientists out there have to think about in this approach if they choose to use that approach.
Yeah, absolutely. So I'd say that data creation and data generation is a really important process of the entire evaluation workflow, and arguably it's actually the very first step in the evaluation workflow. And so, without having a really high quality representative data set that is a large enough sample size that you can really iterate over, it's really hard to even understand whether the evaluations that you're running, the results that you're seeing, are even correct, or whether you should even trust them in the first place. And so I'd say that what we've seen customers start to do increasingly is start to figure out, ways to be able to kind of bring the real world kind of insight and data that they see happening with their product, and to marry that with the internal work that they might be doing around synthetic data generation, to then have a really high quality suite of things that they can really test and iterate over time. And I'd say that that's a process that we're still seeing companies struggle with, and understanding how do you actually create a representative eval data set. That's one of the things that we do on our forward deployed engineering team, is we actually help enterprise customers solve that kind of first problem in pretty creative ways. And one way that we've done that is we've actually developed internal data set generation agents that can actually simulate the process of going through different kinds of documents, and being able to even set up a new RAG system that can then simulate queries, and then to create a data set around that, because then you can use that data set to understand how well is your AI product performing, and how can you make the right kinds of changes towards that. And so I do expect that synthetic data generation is going to continue to be a really big part of the evaluation workflow, and it'll be especially useful for companies that are getting started, because they just don't have enough distribution yet to to really understand how things are going, and that's in many cases that's a lot of where we see the market being today.
Yeah. And Anand, I'm going to ask one more question too before we close out today, but I'm going to ask you for a hot take here. Here we go. Um, I feel like as models come out, um, the first thing that happens a lot of times is, hey, let's go benchmark them. Um, and what is your thoughts on kind of the state of benchmarking in the industry when it comes to optimization? And I've some folks say it's valid, some folks say it's not, some folks say it's the best we can do right now, and then I've seen instances where models are sometimes fine tuned to specifically do well on benchmarks, and so what is kind of give everyone the current state of benchmarking? What's your opinion on all
Yeah,
of that?
absolutely. I'd say I have a lot of strong opinions on this particular question,
I
but I'll
figured
say
if anybody did, it would be you.
that. Yeah, well, it's funny you bring that up because just last week we announced a new agent benchmark with Meta and Columbia University, and it's called Blur, and it's a new agent problem that we tackled, and it's benchmarking is a very big part of not just the evaluation workflow, but a big part of how we think about our product and how we help customers iterate against their own systems, and to do that, of course, in very highly intelligent ways. In terms of what I see for the state of benchmarking today. I'd say that no one is really openly kind of admitting it, but pretty much everyone is training on benchmark data, and either it's a part of the training data set, and no one wants to admit it, or no one wants to come out and say, yeah, I think it was, it probably was, but everyone is training on benchmark data, and so in a lot of ways, especially for kind of academic benchmarks that were released a few years ago, I'd say all of them are saturated. And At Patronus, we don't, in many cases, we don't even trust any benchmark results we see unless there's one of two things happening. One is if the benchmark itself has a portion that was a closed test set, if that makes sense. And so if at least there was some kind of open portion and then a closed portion, then at least we can trust the kind of overall result that we saw. The second is live benchmarks. And live benchmarks are great because they're actually updated every month. And so that's a scenario where we wouldn't expect companies to be able to train on every single version of that and every single new version that's coming up ahead because it just hasn't been released yet. And so unless there are one of those two scenarios, we just don't even trust benchmark results at all. So for that matter, with Blur, which I mentioned earlier, the benchmark that we released last week, we actually released a portion that was open source, and the rest was actually a closed set. And then last year, when we announced Finance Bench, which became a very popular benchmark for finance AI practitioners, we also only released an open source portion, and we had a larger closed source portion, which we have engaged with companies on if they wanted to be able to purchase it. In which case, they actually signed an agreement where they say we won't train on this data. So every single customer that has ever purchased Finance Bench from Patronus for the entire closed test set of 10,000 questions and answers, they're agreeing to never actually train on the data itself. And that's something that we're really proud of because we care a lot about ethics in the research community, and that's a really big part of how we believe research should be done just across NLP in general.
I love that. I love that. That's fantastic. And I think that's a great place to kind of close it out. So, Anand, I certainly appreciate your wisdom and your hot take as well. So, if folks out there wanted to kind of dig in a little bit deeper, reach out to you or learn more about the products, what's the best way to get started?
Absolutely. So the best way to get started is to understand what exactly you want to be able to do with the AI product that you're trying to solve. And If you want to be able to understand how to solve problems related to quality, performance, and even security, of course, feel free to reach out to me or anyone on the Patronus team. And You can, of course, do that directly through our website by booking a call, or of course, you can just go ahead and try out our product. If anyone ever wants to chat about just anything across AI, but especially AI optimization and evaluation, we'd love to have an interesting conversation.
Fantastic. Well, Anand, thank you very much for your time today. And everyone out there, thank you very much for listening as well. And of course, if you enjoy the show, please tell a friend. Please, if you can, leave a review wherever you get your podcasts. And of course, we're always welcome to feedback as well. show@thecloudcast.net. On behalf of Brian and myself, thank you everyone for listening this week, and we will talk to everyone next week.